This is constant velocity. Constant velocity just means an object that's moving at constant speed and never changes direction. So that means moving in a straight line. And so we have an equation today for this one. This equation allows us to keep track of the position of some object at time zero and refer to our previous lessons. A position is simply just somewhere on a number line. So if you can imagine a person, here, and then walking over to position 3 meters away, uh, position is just what number we're at. So if they started here, that would be this value, which we call x naught. So this is called x naught. That's how we say it. You can also just say x0 for this one here. We're talking about this one. And the person moved over here. So this would be x naught. This would be x. X is the position of some object at a later time. Okay. This one we just call x. I mean, that one's easy to pronounce. Most students will say x0. Um, having done this for a long time, we, as physicists, just use x naught as the description. That's what we call it. We want to write the units that these are in. Both of these will be in meters. Okay. So over here, we're measuring position 0, 1, 2, 3 meters. That's the unit apart. That's the unit that they are apart, is 1 meter. Okay, v is our constant velocity for our object. If the object is not moving at constant velocity, if it's not moving in a straight line or moving at constant speed, this equation doesn't work. The units, we pronounce it as meters per second, but you write, maybe the better way to write it is meters over seconds like this. Meters per second is what we say. The way we write it is like that. Okay, and the last thing is time. So this object might be traveling for some amount of time. The units we use there are seconds. Let's go down and do an example. Whenever we do this type of problem, we always want to start with this exact list that we have. We're just going to write that down. And instead of putting descriptions of those, we're going to put numbers. So make a list and write equals. We'll read the problem now. A remote-controlled car is moving at a constant velocity of 2 meters per second. If the car is moving for 4 seconds, how far did the car move? So I think for now, I'm going to actually show this just to give us a visual. And first thing we want to do is take the numbers that they've given us and put them in the list. Because if we look at the units that we described earlier, if you have a number that's in meters, that's going to be a position. If you have a value that's in meters per second, that will be the constant velocity. And if you have a unit that's in seconds, that's the time. And so I always use the units to tell me where to put these numbers. 4 seconds is always one of the easiest ones when we have seconds. So we'll put 4 seconds there. Constant velocity, that's 2 meters per second. And so that tells us that goes here on the list. And that's actually all the numbers that they give us. Now, when they ask how far something went, okay, let me do it this way. How far something went would be considered x. So let's say this is 0, and the object started here at 0. I know it's a car, but I'm drawing a person. Um, if they start at 0 and they travel to this position x, that's how far they traveled. I can count them. This would be 1, 2, 3, 4 meters. But my point is that when they don't give us the starting position, let's just call that starting position 0. So we actually have a car. Okay. Oh gosh, it's giving me straight lines. Let me see here. Let's do it like this, piece by piece. Drawing a nice 70s car. So let's say it's starting on this position. We'll just call that 0. And however far the car goes, we'll just um, call that x and we'll calculate it. Okay, we're going to use our equation, and which is written up here. So I'm just pulling it from the top. X is equal to x naught plus v times t. That's what that means. So some number equals x naught plus, this is v times t. We're going to substitute all the values that we know. And I always start with the left one. I always start here. And I see if I can substitute some values for it. So because we don't know x, there's nothing written here, I'm going to leave it as x. And that's what you should always do when you don't know a variable. You just leave it. You cannot put 0 for it. You can't just make up a number for it. We need to figure out what that number is. Turns out that x naught is one of the numbers we can always put a 0 for, typically, if it's not stated. And you know what? I'm going to write that down. We want to write that down. If not stated, I should say if not otherwise stated, x naught is equal to 0. If I say the starting position is at 2, well, then you should put a 2 there. But if it's not stated, then you just make it as 0. So I could put a 0 here to substitute that number, but I'm not going to do that. It's much easier for us if we just cross it out and we put a 0, put a little arrow crossing it out and put a 0 there, just to show that we are taking it out of the equation, because 0 plus vt is just v times t. It's just vt left over. Now I know v and t. They're right here. So I know the numbers. I'm going to substitute them. And when you substitute numbers, you should always put them in parentheses. So v is 2 and t is 4. And we just calculate that. 4 times 2 is going to be 8. And the units for position for x, remember we said is in meters. That's how I know what the units are. And I'll just say this, you should memorize the units. I always give you all the equations on tests and quizzes. I will always give you, of course, this. What I don't give you are these, the units. So you should really memorize them. They're not very hard to memorize. They actually make a lot of sense if you think about them. Time is measured in seconds. A position is measured as a place, like meters. And velocity is a unit of distance over a unit of time. That's why it's meters per second. So the first one's done. That's how far the car moved. I'm going to go ahead and move on. We'll do one more example on this video. We'll start with our list. You don't even have to read it yet. Make the list. Now don't just put 0 right away in that x naught. Let's wait to make sure it doesn't say what it is. It says a car is moving with a constant velocity. Sorry, constant velocity. A car moving at constant velocity travels 200 meters in 8 seconds. What is the car's velocity? So a lot of students see velocity and then they see this number and they want to put 200 here, which is incorrect. So why is it incorrect? Velocity is in meters per second, okay, meters per second. And the units that they give us here is not meters per second. This is meters and seconds. What they've given us is some position. Maybe it's x naught, maybe it's x. And they've given us the time. So time is very easy. It's usually one of the easier ones. And we need to think, is this the starting position of the car, or is this 200 meters the final position of the car? Well, it says it travels that far. So I'll get my number line here. Here's the starting position x naught. Now if the car, and I'm not going to take the time to draw a car, if the car travels 200 meters, I would argue that that is the final position x. And that is going to be true if this is also 0. This is one of those cases where we can put 0. On your assignment for uh, this lesson, one of the questions at the end does tell you x naught is some other number, but for the first few you can write 0 for that one. Let's calculate it. We'll substitute starting on the left. We do have a number for x, that's 200. X naught is 0, so I'm not even going to bother writing it down here. V is unknown, so we leave it as V. And t is 8 seconds, which I will go ahead and put in parentheses. To solve this for V, we need to isolate V, and so we need to get rid of the 8. What we do is we divide it, and that's just algebra. Okay, let's see here. 200 divided by 8 sounds like 25 to me. It is late in the day and I am very tired. So let's grab that calculator. And it is 25 indeed. So we will write 25 as well as the units for velocity, which is meters over seconds. And sure enough, you will get used to those units. You will memorize them. Okay. But that's it for constant velocity. That's enough for you to know to solve the assignment.